Hi guys, this is your channel Stat and Math Tutorial in a new video. Today I'm going to show you how to find a closed formula for locus numbers. So let's start. So the recurrence relation for locus numbers is ln equals ln minus 1 plus ln minus 2 with the initial condition L0 equals 2 and L1 equals 1. So let's use the technique of the characteristic equation to find a closed formula for locus numbers. So first let's move everything to one side and make it equal to 0. So ln minus ln minus 1 minus ln minus 2, the whole thing equals 0. So now the characteristic equation looks like x squared plus alpha x plus beta equals 0. So in this case alpha is negative 1 and beta it's also negative 1. So we will try to find the roots of this quadratic equation, x squared minus x minus 1 equals 0. And we're going to use the quadratic formula, which is, change the color here. So the quadratic equation, x will be negative b plus or minus b squared minus 4ac square root and the whole thing divided by 2a. So now b is negative 1, a is 1 and c is negative 1. So x equals minus 1 is positive 1 plus or minus b negative 1 squared it's 1 minus 4 times 1 times negative 1 square root everything and divide by 2 times 1, which is 2. So I end up with 1 plus or minus square root of 5 divided by 2. So those are the roots of the characteristic equation. So that's mean ln it's a which is a constant and does not matter which root you put first. I'm just gonna go with the positive 1 plus square root 5 over 2, the whole thing to n, plus another constant b and the second root 1 minus square root of 5 over 2, the whole thing to the end. And now we need to find out the constants a and b, and we're going to use the initial conditions to find out a and b. So we know L of 0 it's 2, which is gonna be a, and change n with 0, so it's gonna be 1 plus square root of 5 over 2 to 0 power. Same thing, b times 1 minus square root of 5 over 2 to 0 power. So that leaves me with the first equation, a plus b equals 2. So that's my first equation here. I have two unknowns, so I need two equations. So this is the first equation. And the second initial condition, L1 equals 1. That's mean A times 1 plus square root of 5 over 2, the first power, plus B times 1 minus square root of 5 over 2, first power. So that leaves me with the second equation, which is A times 1 plus square root of 5 over 2 plus B times 1 minus square root of 5 over 2 equals 1. And that's my second equation. Now I have two equations, two variables. I can solve a system of equations using whatever method you are comfortable with. I'm just gonna do a substitution here, but you can use elimination, you can use Jordan elimination method, whatever way it's easy for you. So let's solve this system of two equations. So the first one, A plus B equals 2, and A times 1 plus square root of 5 over 2 plus B times 1 minus square root of 5 over 2 equals 1. I'm just gonna solve for B in the first equation in terms of A. So A plus B equals 2, that leaves me with B equals 2 minus A. And now I'm gonna substitute 2 minus A for B in the second equation, which is here. I get A times 1 plus square root of 5 over 2. B is plus B, which is 2 minus A, times 1 minus square root of 5, the whole thing over 2, which equals to 1. And now let's simplify a little bit here and try to find A. So I have only one variable now. I can solve for it. So if you multiply A here by 1 plus square root of 5, I get A plus A square root of 5 over 2 plus 14 here over 2, and I'm gonna distribute this these two expression here. So 2 times 1 is 2. 2 times negative square root of 5, so it's minus 2 square root of 5. Now I'm moving to negative A times 1, it's negative A. And negative A times negative square root of 5, it's positive A square root of 5. And of course everything equals to 1. Now I have a common denominator, which is 2. I can add everything on the top here. So 2. I have A and negative A cancel each other. So A and negative A cancel each other. I have A square root of 5 and A square root of 5. That's mean 2 A square root of 5. So I have two of those. So 2A square root of 5 and I have 2 minus 2 square root of 5 plus 2 minus 2 square root of 5, and everything equals to 1. Now I can cancel the 2, or I can multiply both sides by 2 to get rid of the denominator. Yeah, I can factor 2 on the numerator and cancel the 2's, or you can multiply both sides by 2, which what I'm gonna do. Multiply both sides by 2, I get 2a square root of a square root of 5 plus 2 minus 2 square root of 5 equals 2. And now you can cancel the 2's. So the 2's, so it's like dividing everything by 2. So I get a square root of 5, so it's gonna be plus 1 minus square root of 5 equals 1. And now if you subtract 1 from both sides, I get a square root of 5 minus square root of 5, which equals to 0. And then add positive square root of 5 to both sides, I get a square root of 5 equals square root of 5. And that's mean a equals 1. So I find a now. Now let's find out what's b. So using the first equation, which is easy, so we know a plus b equals 2. A plus b equals 2, and a is 1, so it's going to be 1 plus b equals 2. That leaves me with a b, it's 1 as well. So now I have everything to finish the question and finish the closed formula for locus number, which is ln equals 1 plus square root of 5 over 2 n plus 1 minus square root of 5 over 2, the whole thing to n. And let's double check the initial condition and see if we did everything right. So we know L of 0 is 2. So L of 0, it's gonna be 1 plus square root of 5 over 2 to 0 plus 1 minus square root of 5 over 2 to 0, which is 1 plus 1, and that's 2. Bingo here. Let's try L1, which is 1. So L1 equals 1 plus square root of 5 over 2 to 1 plus 1 minus square root of 5 over 2 to 1, which is, so I have a common denominator too, so 2, 1 plus square root of 5 plus 1 minus square root of 5, which is 2 over 2. So the square root of 5 cancel each other, which is 1. And voila, this condition has been met as well. So we are good to go. So this is the closed formula for Locus numbers, given those initial condition L0 equals 2 and L1 equals 1. I hope you enjoy watching this video. I will pause here and continue next time. Thanks for watching.